We find the derivative of f of t. We differentiate f of t, which is a function of t. Note that k is a constant. We differentiate it with respect to t. So f prime of t, so it's something like x to the n. So that is k t to the k minus 1. So that's the first derivative. The second derivative we can get by differentiating this once again. So k is a constant, we leave that alone, and we go d by dt of t to the power of k minus 1. So that is equal to k. D by dt of t to the k minus 1 is k minus 1 t to the power of k minus 1 minus 1. So 1 less than the power, so that would be k minus 2. So that's the second derivative. The third derivative we obtain by differentiating, finding the derivative of the second derivative. So we differentiate this expression. Since that part is a function of t, the rest are constants, we leave them alone. T to the k minus 2. So that is k times k minus 1 times k minus 2 t to the k minus 2, so that's a minus 2, sorry, k minus 2 minus 1, so that is k minus 3. So I'll go one more step so that way you can see the pattern clearly. So I take the fourth derivative by taking the derivative of the third derivative. Leave the constants alone. So the first three numbers are constants, and then we differentiate with respect to t, t to the k minus 3. So we have k times k minus 1 times k minus 2, d by dt of t to the k minus 3 is k minus 3 times t to the k minus 3 minus 1. So this is equal to k times k minus 1 times k minus 2 times k minus 3 t to the k minus 4. So now you can see the pattern emerging clearly. Okay, so let's see what the pattern is. So if it's the first derivative, look at the exponent, it's k minus 1, and it's k times t to the k minus 1. If it's the second derivative, it is k times k minus 1. Notice if that's a 2, this is a minus 1. If that's a 2, this is a k minus 2. This is a 3, this is the third derivative. That's a minus 2, and that's a minus 3. If that's a 4, notice the pattern, that's a minus 3, and that's a minus 4. So if I had to find, I just keep going, f to the 15, right? It's the 15th derivative of this particular function, then it's going to be k times k minus 1, and I keep going until I get k minus 1 less than 15, which is 14, and then I go t to the power of k minus 15. Okay, so now if I had to find the kth derivative, so f k of t, so that is the kth derivative. And what was our original function? F of x, or rather f of t, is equal to t to the kth power. So if I take the kth derivative, let's see what we get. It's going to be k times k minus 1 times k minus 2 and so on. Okay, and it's going to be k minus 1 less than k. Notice if this is a 15, that was a 14. If that was a 4, that's a 3. We subtract a number that's 1 less than the exponent, and then we go t to the power of k minus whatever this number is, k. So that is equal to k times k minus 1 dot dot dot, and this is k minus k plus 1. So that's a 1, and that's a t to the 0. T to the 0 is a 1. So what we're left with is k minus 1 dot dot dot. It keeps decreasing and it goes up to 1. Another way of looking at it is 1 times 2 times 3 dot 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 up to k minus 1 times k. So I'm looking at it in the reverse order. And if you've done some probability before, you know that there is a symbol for this. You multiply natural numbers up to k, that's equal to k factorial. So this is read as factorial. It's called the factorial notation. If I go 1 times 2 times 3, that's 3 factorial. 1 times 2 times 3 up to 15, it is 15 factorial. 1 times 2 times 3 up to k, it is k factorial. So the kth derivative of f of t is equal to k factorial. It becomes a constant. We start with a polynomial, it becomes a constant. If I differentiate it once again, remember what we talked about in the first question possibly. If we differentiate a polynomial of degree k plus 1 times, it becomes a 0, because what we have here is a constant. You differentiate a constant, it becomes 0. So every polynomial, if you keep repeatedly differentiating or finding the derivative of the function, higher and higher orders, at some point the derivative becomes a constant, and the next derivative will be a 0.